So check this out for fun. Some paper tubes of different sizes. Maybe you have some old duct tape laying around with some different designs. Scissors and painter's tape. Please don't confuse painter's tape with the duct tape if you're going to be taping it onto the wall. You'll see in my next few steps of directions. But we're going to be engineers this week. Yes, we're going to engineer a tube system to cause something to go from the beginning to the end without us even touching it. How can we do that? First, you could decide maybe if you want to go ahead and decorate all your tubes, you can do that. I think I might just do my beginning and my end with some fancy tape. Again, it doesn't need to be taped. You can just use the plain old paper rolls and the painter's tape to make your system. And again, with permission from an adult, before you get started taping things to the wall, make sure that the tape that you're using, which right here is painter's tape, which I know will be easy to remove from the wall and it won't cause any damage to the paint. All I did was use duct tape to decorate my first paper tube. I decided I wanted to do it with the first tube and my final tube. So I started up a little bit on my wall with my very first tube. Now my question to you is, why did Miss Wendy tilt her tube at a kind of a diagonal, or what some people might call an incline? And I have this round object that I'm going to drop in. What will happen? Right. Gravity will cause it to go down. And so next in my creation of my tube system as an engineer, as we celebrate Engineering Week, I still continue with the incline. But I don't want this tube system to just be a straight down, boring old design. How should I go next? So then I got thinking, if I go a different direction to have some fun with it, what about if I do connect this like this? Look, there's not a hole there. What can Miss Wendy do? And this will be part of your design challenge. How could you make this go a different direction and still allow that tube to go this way and still allow your object to go down and into that next tube? What could we do? Well, my future engineers, you were right. I have to design some sort of an opening within this tube without cutting it all the way through, but still provides a chute to go down. It kind of reminds me of rain gutters in a way. If you ever look at rain gutters, ask a grown-up maybe to help you check out how that's connected to the house and how the water goes down the rain gutter. It's kind of a similar fashion. So all I did was I cut a slit on either side, not all the way down and not all the way around. And maybe if I just fashion it like this, it'll be just enough. Let's tape it on the wall and test it. So I taped it to the wall. You see how I made that little flap opening. So in hopes that when it comes down that tube, it now has a way to go down this tube. So I'm going to go ahead, grab. Now believe it or not, this is just a little wrapped foil candy. I'm sure you probably could find small objects to go in there. But whatever you do, test your theory. That's a whole part of the engineering design process, is testing it. And if it doesn't work, well, you go back to the drawing board and you start again. So let's test it. Uh-oh, did you see what happened? I'm going to keep the camera on this angle so you can see what happened. Well, the first time it came out, it actually shot out of this end. And then this time, there must have been enough energy to shoot it right down to the bottom there. So, what could Miss Wendy do as a part of this trying it out and going back to the drawing board and trying again? What should she do? So I took a spare envelope that was left over And I'm just cutting a little piece off because I thought maybe this would be a little bit kind of stiffer. And then maybe I can kind of come up with some sort of solution to just block that off, right? So it doesn't try to fly out that end again. Well, it doesn't have to look pretty, but it will do the job, I hope. So I'm going to test it again. I'm going to watch that corner there, okay? So if I drop my round ball type object, which, as I said again, this is just little candy. Maybe you have a small bouncy ball or some other round, smaller thing that will fit through the tube that you can test with. So here we go. I'm going to watch that end to make sure it doesn't come flying out. It did just what it was supposed to, and it shot right out. I wasn't quick enough with my camera to show you that. Yay! So now I can progress to the next part of my tube system, which would be to connect further down. And now, after several tubes, I got to the next point. I tested it. It did shoot right down. I wanted to point out that as this tube is a little bit smaller than that tube, so I tried to tuck it kind of in there. So you might find, as you are the engineer designer, to test that theory out yourself. All right, I feel like I have enough room to do some more. What do you think? Uh-oh, maybe I'm gonna have to do the same kind of patching on this end. I'll have to test it to see if it works. Start at the top with my colored tube and make its way down, 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 down. It should come right out here. So I'm gonna hold us right here so we can watch. It worked! And so my final tube, as I had presented in the beginning, I wanted to make a fancy color. Again, you don't have to make fancy colored tubes. It could just be all just the regular paper tubes and your painter's tape. Maybe having to put a little elbow there to connect it so it doesn't come flying out the end. But I thought it would be fun to, at the very end, have a bowl. And this bowl is made out of ceramic. Maybe you have a metal bowl, but it might make a cool sound. So I'm going to test that out. Going to go pretty fast here, folks. Oh! That was a cool sound. Now, I had some other round objects that I thought I might try. I had this round bouncy ball, but when I tried it, I realized, well, look at that. It's way too big. So, back to the drawing board, Miss Wendy went. And I decided maybe I could try this pom-pom, which I might try one round. I also was thinking about, in my refrigerator, I had a blueberry. And I also had a round M&M candy. So let's start with the blueberry. Test the theory and see if it works in my own design tunnel system. Uh-oh. Sounds like it got stuck. That's not good. So, that theory out the window. How about my M&M candy? Did that work? Oh, it came flying out so fast it didn't even hit the bowl. How about this very fluffy, fun pom-pom ball? I can hear it. But it sounds like it might have gotten stuck. So my friends, you can test all different types of objects and create your own engineering project, pretending that you're a future engineer designing a tunnel system. I know in the past my children had made a vending machine and they pretended, you know, that you had to put money in it and then that candy would come out at the bottom. You could do that as well. Have some fun with it. And instead of a wall, you could set it up with the side of a cardboard box. You know what? The sky's the limit. Just attack your recycle bin and have some fun, my future engineers. Interested in discovering more about engineering? No further to look than the Manlius Library. Here are some interesting titles, including some biographies, such as The Ferris Wheel, some other books that might be enjoyable as well for Gutsy Girls Go for Science Engineers. Another biography, this one giving us an insight with Thomas Edison and all the inventions. Science Builders presents electrical engineering. A couple of fiction books, Ellie the Engineer and Astronauts. Your own kind of fun, building structures and towers. You could pretend you're an engineer. Some insight on mechanical engineering, as well as taking a dive into computer science and programming. Some more information on environmental engineering, and some more how-to fun with out-of-the-box 25 different projects for engineering. You can find these and more at the Manlius Library.